Welcome, folks, back to Precalculus. Today we're in Chapter 3, Section 1, talking about quadratic functions and applications. Okay, so just a quick refresher that the standard form for any quadratic equation is f of x or y equals a times an x squared plus b times an x plus c, as long as a is not equal to 0. So we got to have an x squared term in there. So basically, the a is telling us if the parabola opens up, a is going to be greater than 0. And if a is less than 0, the parabola is going to open down. Okay. Now, getting the parabola from standard form to general form, which is, if we have a refresher, x minus h quantity squared plus k, with our vertex being at hk. Once we get it in this form, it's going to be easy to graph and shift around. Okay, so we're going to have to take our standard form. We're going to have to complete the square. And here's just a refresher on how to complete the square. Basically, you want to make sure your leading coefficient is not 1. So you're going to factor those things off, and then b over 2 squared. So anyways, when we get it back into this standard form here, or this general form, sorry, the h is going to tell us the left or right shift. The k is going to tell us whether to go up or down. And refresher from previous notes, the a is going to tell us the vertical stretch or shrink. Okay, could be a shrink. All right, so what we're going to do once we have that is we're going to plot the y-intercept at 0, whatever. Okay, and then we're going to reflect a point over the axis of symmetry, and we'll be good to go. Okay, so we're going to practice that right now. So let's take a look at this example here. So right away we can tell it's not in general form. It's not in general form. It's in standard form. So we want to go ahead and complete the square. So I'm going to factor 2 off, x squared plus 4x, and then we're going to add a blank and subtract the blank, and we're going to add 7. Okay, so remember, completing the square is b term divided by 2. 4 divided by 2 is 2. Squared is 4. And then we're going to factor the first 3 terms, and we're going to end up with 2 times x plus 2 quantity squared. Now, this is not a minus 4. Remember, this minus 4 was created from this 4 right here by completing the square, which had a 2 pulled out of it, which used to be an 8. Okay, so this 2 has to go back in. That negative 4 is actually a negative 8. We got a plus 7. So our equation is going to be 2 times the quantity x plus 2 squared minus 1. So we can see right away that this is left 2, down 1. Left 2, down 1. And if we plot our y-intercept, you can look back at the original equation if you want. The y-intercept is going to be 7. You plug in 0 for x, 0 plus 0 is going to be plus 7 is going to be 7. Okay, so let's go ahead and plot that. And if we recall, we have down the middle of our, drawing it really light, but down the middle through the vertex, we have an axis of symmetry. So that point that's on either side of the axis of symmetry can be reflected directly over it. So this point right here is 2 units away from the axis of symmetry, so we're going to go 2 units in the other direction. It's going to help us make a parabola. Okay, now the next one, very similar. I want you guys to pause your video and do the next one. Just making a quick note that there is a negative here. You're going to have factor a negative sign off of the first 2 terms, just like we factored a 2 off up here. So pause your video and see if you can get this one graphed. Okay, now we're back and we're going to talk about a different way of graphing a parabola, and that's by using the vertex formula. Okay, so the vertex formula, to find the vertex, the x-coordinate is always going to be negative b over 2a. And then the y-coordinate is always going to be, just plug that point, negative b over 2a, into your function and see what you get. Okay, so let's take a look here at our function really fast. Okay, so x equals negative b, so 1 over 2a, which is 1/4. Okay, so our vertex is going to lie somewhere on the axis of symmetry, which is the vertical line x equals 1/4. So if I'm drawing it really light, somewhere in here. It's very light, but you can see it. So now let's take 1/4 and plug it into our function. So f of 1/4 is 2 times 1/4 quantity squared minus 1/4 plus 1. 1/4 squared is 1/16 times 2 is 1/8 minus 2/8 because that's 1/4. It's doing common denominators plus 8/8. So 1 minus 2 is -1 plus 8 is 7/8. So 1/4, 7/8. Your vertex should be about right there. Vertex 1/4, 7/8. Now to find the y-intercept, it's 1 because just look at the original equation, plug in 0 for x, should be 1, and then reflect it over. So if the axis of symmetry is 1/4 of a unit away from the y-intercept, then we should go 1/4 of a unit the other way. It's very tight, but you can see how the parabola is made. Okay, so combining the new strategy with the old strategy with the axis of symmetry from last example. So go ahead, use the vertex formula now. Pause your video, use the vertex formula to find the x-coordinate, and then plug it into your function, find the y-coordinate, and plot the y-intercept of 21. You might need to change your axes around a little bit. That's okay. Okay, and graph your parabola. So pause your video, give it a shot. Okay, now we are going to be finding the equation from a graph, and we're going to be putting those equations into vertex form, general form, whatever you want to call it, this form of the equation. Okay, so first we have to find the vertex at hk, and then we're going to plug in a given point for x and y, and we're going to solve for a. So it's going to be really super simple. Okay, so we know that we want our equation to look like a times x minus h quantity squared plus k. So if we look at this graph, we're just going to start filling in pieces. Okay, so the vertex is very clearly at -1, 2. So we're going to plug in -1 for h. So that's going to make that x plus 1 squared. And up to, beautiful. You should recognize that as being a left 1 up 2. Okay, so now for solving for a, we need to find any point that's not the vertex. Just don't use the vertex. Use any other point on the graph, anything easy, and then plug it in for x and y, solve for a. So what I'm going to do is I'm going to choose this point right here, 1, 0. Okay, so that means I'm going to plug in 0 for y, 1 for x, solve for a. So 0 is equal to 4a plus 2. A is equal to -1/2. So my equation is y equals, or f of x equals, doesn't matter, -1/2 x plus 1 quantity squared plus 2. And there's our final equation. So right now, what I want you guys to do is pause your video, and find the equation for this graph right here. Okay, they give you some x's and y's to use. Since the x-intercepts are not so obvious, there's the vertex. You should be able to do it rather quickly. Pause your video, give it a shot. Let me know if you have any questions. Okay, last part of the day here. So we're going to talk about the solutions of a quadratic equation. Okay, so just like the various standard forms, quote unquote standard forms, there's different ways to talk about the solutions. Well, solution spelled wrong, I guess. So anyways, so if x equals r is a solution, or we can call it a root of an equation, then that's the answer you get when you set the equation equal to 0 and solve. Okay, so that would mean that the answer you get is an x-intercept at r0, and that you can turn that into a factor of your function, okay, which we're going to be using a lot more later in this chapter, okay? Lastly, last word we can call a solution, a root, an x-intercept, a factor, or a zero, as it's commonly referred to as, because it does hit the zero of the x-axis. Okay, so let's take a look at an example here and do a little real-world application of quadratic formulas. So we got a baseball player, they hit a ball, and the path of the ball can be described by this equation. Okay, so I don't really know too much about this equation other than that it's a parabola opening down. Okay, so if we are so bold as to draw a little small picture of a baseball player hitting a ball. Okay, baseball player hitting the ball. So we can call the x-axis, as we commonly do in physics, time, and we can call the y-axis height. Baseball, there's a baseball right there, poorly drawn baseball. Okay, maybe you got a little stick figure guy hitting his baseball bat, hitting the ball. Okay, and the ball is going to go like this. And notice the ball is off the ground because it's pitched to him, and you can tell that it's going to be off the ground when it's hit at time 0 because the y-intercept is 3. All right, so this is essentially what's happening. Now, we're being asked, what is the y-intercept of this equation? What does it represent? Well, the y-intercept is very clearly 0, 3. You don't have to know much about it. Just plug in 0 for x, you get out 3. What does it represent? The height on impact. So whenever the ball is being hit by the baseball bat. Okay, so we're being asked how many seconds does it take for the ball to reach its maximum height. Its maximum height. And then we're being asked the next question, what is the maximum height? So basically we're being asked, what is this coordinate right here? How many seconds? Time? That'll be the x coordinate. And what is the maximum height? That'll be the y coordinate. We just need to figure out what this is. And to do that, you're going to need a calculator. Okay, so what I've done, and you may want to pause your video, but what I've done is I've gone ahead and put that equation into my y equals, and we'll go ahead and graph it. Okay, so if we go ahead and graph it, you're going to see really quick that you can't really tell. You know what it should look like. You know what this parabola should look like, but you can't see it in your graph. Okay, so one commonly used feature on this calculator is you can zoom, and you can go ahead and zoom out a few times if you want. I'm not going to do that just yet. I'm going to go ahead and just test out zoom fit and see how it works. See if I can see an upside down parabola, and I want to see if I can see the height. So there's my upside down parabola, and I can see there's my max right there. So we got to calculate that max. Your calculator will actually do that for you by pressing second calc. And look right there, option number 4, the maximum. Now it's going to pop up this little crab. It's going to start dancing and flashing around on your screen. Okay, all it's saying is find the left bound of the max. So just go somewhere to the left of the max. Doesn't matter where you go, just somewhere left of the max, press enter. Now it's going to say, tell me somewhere to the right of the max. All I'm just going to do is scroll to the right of the max. Doesn't matter where I go. I'm going to hit enter. So now my maximum, my peak, should be between these two dotted lines that pop up. You can guess if you want, I never do. Okay, and you can see right now that it tells me my maximum is up here when x is 2.1875 and when y is 79.56. So I can go ahead and fill that in. So how many seconds does it take the ball to reach its maximum height? Put it back on my screen there for you. Not a glare. At 2.1875 seconds, and its maximum height is 79.56 feet. Okay, now the last thing that it's asking you to find is how long does it take to reach the ground? How long does it take to reach the ground? Well, that would be this point right here. And we want the how long time, we want the x coordinate. Okay, well, we know that that point right there is commonly referred to as a 0 or an x-intercept. Your calculator will also help you find that in the same exact menu. Okay, so if we press second calc, the second option, 0, now it's just saying, it's going through the same thing. It's going to tell you, hey, go to the left of your 0 somewhere. Just go left. Okay, that's about left of the 0 I want. I want this 0 right here, which is this point on our graph. I'm going to hit enter. Go to the right of the 0. You got to make sure you cross the x-axis. There you go. So somewhere to the right of the 0, I've clearly crossed the x-axis. I've clearly gone to the right of this point. You can guess if you want. I never do. Okay, and 0 is at when x is 4.417 seconds. 4.417 seconds. You'll notice that it doesn't give you a y coordinate of 0. It gives you 1 e negative 11. That means scientific notation 1 times 10 to the negative 11th, which is basically 0.0000000, 11 zeros and a 1. So we can just count that as being 0, even though your calculator is reading something funky. So let me know if you have any questions. I look forward to helping you in class.